to hope you had a lovely half term and are ready to get back into some learning. So only a couple more weeks and we'll all be back together in school. So keep up all the hard work for the next few weeks. We know it's tough, but you've been doing a great job. So let's kick off with some fluency then. So before the half term, we were looking at using the make 10 strategy for addition. Now what we're going to do today is we're going to look at that same strategy, but in reverse. We're looking at it for subtraction. So this time we're starting with a number, a 2-digit number that is larger than 10. So what we're going to do is we're going to first subtract the number of ones that we need to subtract to take it down to 10. And then we will subtract the remaining number of ones to make sure that we're taking away that full subtrahend. So let's have a look at this one for an example. I'm starting with 11. So you can see here I've got one full tens frame and one 1 here. So 1 10 and 1 1, just like our number 11, 1 10 and 1 1. So what we're going to do is we're going to subtract 4. But before we subtract 4 all in one go, we are going to subtract it in 2 parts. We're going to partition that subtrahend, that 4, into 2 parts, and we're going to make 10 first. So you can see here, if I just highlight it for you. There you go. So you can see this here is a full 10. So how many ones do I need to subtract to leave me with this full 10? Well done, I need to subtract this one. So I need to subtract 1 first, and that will leave me with my full 10. And then how many more ones do I need to subtract to be able to subtract that whole 4? Well, you can see that I've got 3 more here that I need to subtract. So my other part is 3. And you can see that I'm still subtracting 4, but I'm just doing it in 2 parts. I'm subtracting 1 and then I'm subtracting 3. So 11 take away 4. Well, I know that 11 take away 1. Now I chose 1 because these 2 numbers here, when I subtract them, they will leave me with 10. So 11 subtract 1 leaves me with 10, and I can tell that here because if I take away the number of ones in this one column, then that will leave me with just the 10 and 0 ones, which is the number 10. And then for the next bit, we just need to use our number bonds to 10. So we just need to do 10, subtract 3. If you know your number bonds to 10, which hopefully by now you do, you will know that you will have 7 left. So our answer is 7. Let's have a look at this one then, and then I'll leave you to have a go at the next 2 by yourself. So 12 take away 5. Well, I am going to subtract 5, but I'm going to subtract it in 2 parts because I need to subtract a certain number away from 12 to leave me with just the 10. So you can see here, this is my full 10. How many ones do I need to subtract to leave me with just my 110? Well, you can see on the tens frame that I need to subtract 2 ones, and you can see from looking at our number 12 that I need to get rid of these 2 ones here. So I'm going to take away 2 first of all, because I know that 12 subtract the 2 ones will leave me with just the 10. And then how many more ones do I need to take away to make sure that I've taken away, I've subtracted the whole of this 5? Well, you can see that I need to take away 3 more. And again, if you know your number bonds to 10, you should know that 10 take away 3 leaves you with 7. So what we did there is we started with 12, we took away those 2 ones to leave us with just the 10, and then we took away 3 more to make sure that we took away our whole 5, and that left us with 7. Why don't you pause the video and have a go at working out the other 2 by yourself. Great, well done. Hopefully you've had some time to do that now. So let's have a look. So 13 take away 6. Well, the first thing that I need to do is subtract the number of ones that will leave me with just my 10. So what do we need to subtract from 13 to just leave us with 10? Well, I know that 13 has got 3 ones. So I need to take away these 3 ones first of all, and that will leave me with 10. But I didn't want to take away 3, I want to take away 6. So how many more ones do I need to take away to make sure that I've subtracted my whole 6? I need to take away 3 more. Now I know that 13 take away 3 is 10, and 10 take away 3 more is 7. Well done if you got that one right. Let's have a look at this one then. So 15 take away 8. So I'm starting with 15. How many ones do I need to subtract from 15 to leave me with just my full 10? Well, you can see that it's got 5 ones, so I need to take away these 5 ones that are in 15 to leave me with that whole 10. So I'm going to do 15, take away 5 first, because I know that leaves me with 10. But I didn't want to just take away 5, I wanted to take away 8. So how many more ones do I need to subtract to make sure that I've subtracted 8 altogether? Well, I need to take away 3 more. And I know my number bonds to 10. I know that 10 take away 3 leaves me with 7. Well done if you got that right. Okay, great. So we're going to move on to some new learning this week. Now, normally we'd spend a little bit longer on this, but we're trying to prioritize the things that we think are the most important. So what we're going to do, we're going to have a quick 4 days looking at fractions. So a fraction is an equal part of a whole. Can we say that together? A fraction is an equal part of a whole. So you have a whole, and that whole could be a shape, it could be a number, it could be a series of objects, but you have a whole amount. And when you cut that whole amount up into equal parts, then that part is a fraction of the whole. So a fraction is an equal part of a whole. So I have got some examples of some fractions here, and the red part is the part that I have got. So what you need to have a look at is the red part in each shape equal to the other parts of the shape? Equal means the same proportion, the same amount, the same size. So just have a look. Is this red part here equal to all these other parts? Well, hopefully you will have noticed that this part is bigger than the other parts. So these are not split into equal parts because these are the same size, but this one is larger. Is this red part equal to the other parts in this whole? Yes, it is. Well done. What about this part here? Is this red part equal to the other parts in our whole? Yes, it is. Well done if you said that as well. Is this red part here equal to the other parts in this whole? Well done if you said no, it's not. Is this red part here equal to the other parts in my whole? Yes, it is. Well done. So you might notice that, for example, this is the same shape, but it's just on its side. This is the same size part, but it's just flipped upside down. This is the same shaped and sized part, but again, it's just on its side. So it doesn't have to be the exact same direction. It doesn't have to look perfect to it, but it has to be equal. So just because it's tilted on its side doesn't mean it's not equal, because it's still the same amount inside there. This red part here, is that equal to the other parts in our whole? No, it's not, because this part is much larger than these two parts here. Is this an equal part of my whole? Are my other parts equally sized to this red one? Yes, it is. Well done. And what about this part here? Is this equally sized to the other parts in the whole? No, it's much bigger than some of the other parts, isn't it? What about this here? Are the other parts in my whole equal to this portion that's shaded? No, it's not. Well done. This one is much bigger than this one, for example. And what about this one? Is this part that's shaded equal to the other parts in the shape? Yes, it is. Well done. Remember, it doesn't have to be exactly the same. Just because that one is an upright triangle doesn't mean that this is not equal. Just because it's upside down, it's still the same amount inside that space. So well done if you got all of those right. So let's just repeat that one more time. A fraction is an equal part of a whole. Excellent, well done. Now we write fractions like this. We write a number on the top, then we write a line, and then we write a number on the bottom. Now the top number is called a numerator. Numerator. Well done. And the numerator shows us the number of parts that are shaded. That's the number of parts that we have. Now the bottom number is called the denominator. Denominator. Well done. And the denominator shows us the amount of equal parts in the whole shape. So let's have a look at our whole shape here. My denominator is 2. So that means my whole is going to be split equally into 2 equal parts. So I'm going to split it into 2. Oh, let me change that colour. There we go. So I've split my whole into 2 equal parts. Now I know I had to do it into 2 equal parts because my denominator says 2. Now if I have, for example, the number 1 here, that means I have one of those parts. So one of those parts would be shaded in like this. So when the denominator is 2, so when this bottom number is 2, we call it a half. 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 Well done. And hopefully that language is already familiar to you from when we looked at our times tables and we looked at doubling and halving. Remember, when we halve, we split something into 2 equal groups. So this is our whole shape and we split it into 2 equal groups. That's what our denominator shows us. And then the numerator, the number on the top, shows us that we've got one of these parts shaded in. So we would say that 1/2 of this shape is shaded. Let's have a look at this one then. So the top number is called the numerator and the bottom number is called the denominator. Now, for the most part, you want to look at your denominator first. So the denominator in this fraction is 3. Now, who can remember what the denominator shows us? The amount of what in the whole? Well done if you said the amount of equal parts. Fantastic. So that means that my whole has to be split into 3 equal parts. So each of my parts must be the same size. So I've split my whole into 3 equal parts. There you go. 1 equal part, 2 equal parts, 3 equal parts. Now the numerator, let's say my numerator is 1 again. That means the amount that we have. Well done. It's the amount that we have, the amount that we use, the amount that is shaded. So that means 1 of my 3 parts has to be shaded. There you go. Now, when the denominator is 3, we call it a third. So just like here, we would say 1/2. We would say 1/3 of this shape is shaded. Now, if I change my denominator, instead of it being 1, I then had 2, how would my shape need to change? What would I need to do to show 2/3 instead of 1/3? Well done. I need to shade another one of my parts because my numerator is showing me the number of parts that I have, number of parts that we have got shaded in. So now 2/3 of my shape is shaded. 2, the numerator, is representing the number of parts that I have shaded, and 3, the denominator, is representing the number of parts that make up the whole shape. Let's have a look at another example. So this fraction, the denominator, is 4. So what is that going to show us about our shape? We need to split our shape into 4 equal parts. Well done if you said that. So when we do 4 equal parts, what we need to do is we need to half it. And then we need to half it again. There we go. So I've halved my shape and then I've halved it again. So now I've got 4 equal parts. You can see that all the parts within this whole are the same size. They are equal. So the denominator is 4. This means that my whole is split into 4 equal parts. Now, when the denominator is 4, we call it a quarter. Let's have a look at that word. Quarter. Fantastic. So let's say that my numerator now is 1. I would have 1/4. So what does that mean I have to do to my shape? That means I have to shade one of those parts on my shape. Well done. What if I changed my numerator to 2? What if I now have 2/4? What do I need to change over here? Well done. I need to shade 2 of my quarters. Do you think it matters which 2 I shade? No, because they're all equal. There we go. So now 2/4 of this shape is shaded. What do you think would happen then if I changed my numerator to 3? And this time I had 3/4 of my shape shaded. Well done if you said that we need to shade another one of our parts. Does it matter which other one I shade? No, because they're all equal. I could do this one or I could do this one. There you go. So now 3/4 of my whole is shaded. Fantastic. So how about you, I tell you what, I'll go through the first one and then you can pause the video and go through these yourself. So let's work out what this fraction is. Now, like I said, a fraction is written with a number on the top, which we call the numerator, a line, and then a number on the bottom, which we call the denominator. Now, the denominator is what we should look at first. This tells us how many equal parts there are in the whole. So how many equal parts are there in this whole? So this is my whole shape, and I can see that my whole shape has been split into 1, 2, 3, 4 equal parts. So my denominator is 4. How many of those 4 parts have been shaded? So out of my 4, how many are shaded? Well, I've only got 1 shaded square, so that means my numerator is 1. And my numerator tells us how many parts we have. Now, I know it is 1. What do we call it when the denominator is 4? We call it 1/4. Well done if you said that. So I know it is 1/4 quarter because it has 4 equal parts and 1 is shaded. So why don't you pause the video, have a go at looking at these next two, and then coming back to the video to go through the answers. Well done for having a go, year two. Let's go through the answers then. So fractions are written with a numerator on the top and a denominator on the bottom. The denominator tells us how many equal parts there are. So in this whole shape, which is a circle, I have got 1, 2, 3 equal parts. So my denominator is 3. The numerator tells us how many parts we have. So how many parts do I have shaded? Just the 1. Excellent. So I know it is 1. What do we call it when the denominator is 3? 1/3. Well done if you said that. So I know it is 1/3 because it has 3 equal parts and 1 is shaded. Excellent, well done. Let's have a look at this one then. So the denominator tells us how many equal parts there are. There are 2 equal parts in my whole, 1, 2. So my denominator is 2. How many of those parts are shaded? The numerator tells us how many parts we have. So how many are shaded? 1. So that goes on the top. When my denominator is 2, we say that we have got 1/2. Well done if you said that. So 1/2 of this shape is shaded. I know it is 1/2 because it has 2 equal parts and 1 is shaded. Now just have a look at all these fractions. Do you notice anything about them in common? Well, hopefully you've noticed that they all have a numerator of 1. So when we have a number with a numerator of 1, we call it a unit fraction. Unit fraction. Well done. And all that means is that it's a fraction where the numerator is 1. One of those parts in the whole is shaded. That's all that means. However, the numerator can also be bigger than 1, and that would be called a non-unit fraction. Can we say that? Non-unit fraction. Well done, everyone. So let's have a look at this one. I will model this, then you can pause the video and go through these by yourself. So start with the denominator. The denominator tells us how many equal parts there are in the whole. So in my whole, I've got 1, 2, 3, 4 equal parts all together, included the shaded and not shaded. Everything together is shown by your denominator. So I've got 4 equal parts there. Now my numerator tells me how many parts we have. So how many of those parts have been shaded in? Well, I can see 1, 2 of them are shaded in yellow. So I would say that I've got 2 quarters, and I know it is 2 quarters because it has 4 equal parts and 2 are shaded. Fantastic. Why don't you pause the video and have a go at filling in the rest by yourself. Brilliant. Well done if you've had a go at that. Let's go through the answers then. So the denominator tells us how many equal parts there are. So in this whole, I can see that I've got 1, 2, 3, 4 equal parts. So my denominator is 4. And the numerator tells us how many parts we have. How many of those parts are shaded? 1, 2, 3. So we would say that we've got 3 quarters. And I know it is 3 quarters because it has 4 equal parts and 3 are shaded. Did it have to be those 3 that were shaded, or could it be any 3? Well done, it could be any 3 whatsoever, as long as it was only 3 out of the 4. And then the final one then, the denominator tells us how many equal parts there are. In this whole, there is 1, 2 equal parts, so my denominator is 2. How many of those parts do I have that are shaded? 1 blue shaded part. And we would say that we've got 1/2 of the shape shaded. And I know it is 1/2 because it has 2 equal parts and 1 is shaded. Well done if you got those right. So having a look at this then. What fraction is being shown? Well, let's have a look at the denominator. The denominator tells us how many parts there are. 1, 2, 3, 4. Well done, I've got 4 equal parts. How many of my equal parts are shaded? Oops, Daisy. Fantastic, they are all shaded. So 4 parts are shaded. So we would have 4 quarters. Now, when we have 4 quarters, that is the same as a whole, because the whole of my shape has been shaded. We've shaded the entire thing. So what you might notice is that when your numerator and your denominator are the same, that means out of all of these parts, all of them are shaded. So that is equivalent, that is equal to the whole. So let's have a look at these ones. What would we say these ones are? Can you work them out? Pause the video to give yourself a little bit more time. Excellent. So my denominator here is 2 because I've got 2 equal parts in my whole. How many of these parts are shaded? 2 of them are shaded. So I've got 2 halves. And here I've got 3 equal parts. So my denominator is 3. How many of them are shaded? All of them are shaded. So I've got 3/3. Now, all of these fractions where the numerator and the denominator are the same is equal to 1. And that 1 means 1 whole. It means the whole thing is shaded. So it doesn't matter what the numerator is and what the denominator is, as long as they are the same, that fraction is equal to 1. And that 1 means 1 whole. Fantastic. So let's have a quick look. We are going to have a quick look at finding half of these shapes. So what we need to do is we need to split them into the number of parts shown by our denominator. Remember, it doesn't matter what shape you have as long as those parts are equal. So 1/2, that means I need to split it into 2 equal parts. So I could split it in the middle this way. If you're splitting it into 2 equal parts, you're going to split it in the middle. So I could split it that way in the middle. Or I could split it that way in the middle. Think back to your lessons on symmetry for this one. Or I could even split it diagonally in the middle. Let's leave it with that one. So now that I have split my whole into 2 equal parts, now I need to look at my numerator. My numerator shows me 1, so that means I have 1 of these parts. So I'm going to show that I have 1 of them by shading it in like this. Hopefully you'll do a much nicer job of your shading than me. There you go. 1 of these parts is shaded. So I've got 1/2 of this shape. Can you have a go at pausing the video and talking about where you think we should split these shapes? Great, hopefully you've had a go. So let's have a look. 1/2. So the denominator shows me that I need to split it into 2 equal parts. When I have 2 equal parts, I usually just have to split it down the middle like that. So now this part is the same size as this part. Now time to look at our numerator. Super, that means I've got one of my parts shaded. So doesn't matter which part is shaded. Oops, a daisy. Just shade it. There you go. Well done if you guessed that and you got that right. Fantastic. It could have been this part as well that was shaded. Like I said, doesn't matter as long as only one of those two parts is shaded. Fantastic. So now we need to find 1/3. So looking at our denominator, how many parts is this whole going to be split into? That's right, it's going to be split into 3 equal parts. Now, obviously, we don't have any exact measurements. We've just got to do this by eye. They look roughly equal to each other. So let's say that's 3 equal parts. Now time to look at our numerator. How many of those parts do we have? Fantastic. We have one of these parts. So that means one of them is shaded. I just did this part, I think because it was closest. Did I have to do this part? No, I could have shaded the middle one, or I could have shaded the part at the other end here, as long as just one of them is shaded. Fantastic. And then this one, 1/4. So looking at our denominator, that means I've got to split my whole into 4. So remember, when you're splitting it into quarters, into 4, you usually just halve the whole, split it into 2 down the middle, and then halve it again in a different way. There you go. So I've just halved it, I halved it and halved it again, and that led me to having it into 4 quarters now. Now time to look at our numerator. How many parts do I have? 1, so that means I shade one of them. Shade this one, for example. Could be any one of them as long as it's only one. Well done if you worked that out too. There you go. 1/4 of this shape is shaded. Fantastic. So let's say, going back to our example here, we found 1/3. Now, if I change my numerator, and this time I want to find 2/3, how do you think that changes? Well done if you said that the number of parts that are shaded will be more. So this would be 1/3 because 3 shows me that I've got 3 equal parts in the whole. Here, my denominator is still 3, so I've still got 3 equal parts in my whole, but it is my numerator. Here, I've only got one of those parts shaded. So on this representation, that means I need to have not just one, I need to have 2 of those parts shaded. Did it have to be these 2 that I chose? Not at all. It could have been any 2. So there we go. 1, 2. So this shows 2/3. So that's how it changes when my numerator changes. Okay, just going to model some of these really quickly and then introduce you to your task, because I am aware that it has now been quite a long lesson. So true or false, and how do you know? Time for a bit of reasoning then with everything that you've learnt. This is a representation of a fraction, and this is what somebody thinks the fraction is. You need to say whether this is true for this representation or whether it is false. Remember, true means that it is correct and false means that it is wrong. So this person thinks that this representation is showing 3/4. Well, let's start systematically. Let's have a look at our denominator. So the denominator shows 4. That means there must be 4 equal parts in the whole. So let's double check. 1, 2, 3, 4. Is that correct? Yes, it is. There are 4 equal parts in the whole. Now, time to check the numerator. So let's have a look at our numerator. The numerator is 3. That means that there should be 3 parts shaded. Do I have 3 parts of my whole shaded? How many parts are shaded? 1. Well done. So was this true? No, it was not true. And we say, I know that this is false because it has 4 equal parts and 1 is shaded. And I need to say that it needs to have 3 parts shaded. And I'm going to have a look at this one again, and then you can have a look at the next 2 examples by yourself. So first of all, start by looking at the denominator. The denominator is 1. That means I've got to have 1 part in my whole. Do I have 1 part in my whole? No, I've got 2 parts in my whole. And then if we look at our numerator, 2 parts shaded. Well, if I've only got 1 part, how can I have 2 of them shaded? What do you think the mistake is that the person has made here? Well, if we look at our other fractions, are our numerators bigger than our denominators? Let's just have a look at our example. Have we got any numerators that are bigger than our denominators? We've got some that are the same size, which would make a whole, but do we have any numerators that are bigger than our denominators? No, and that's because if we've only got, oh, look here, for example, if we've only got 2 parts, I can't have more than 2 parts shaded. I can have all 2 of my parts shaded, but I can't have more than that because I've only got 2 of them. So this is a red flag, really, if you see a numerator that is bigger than a denominator at this stage in your learning of fractions. So the mistake that they've actually made is that they've got the numerator and the denominator in the wrong place. So I know that this is false because the numerator and the denominator are switched around. There are 2 equal parts in the whole, so the denominator should be 2, and 1 of them is shaded, so the numerator should be 1. So it should be 1/2 and not 2 once. Okay, why don't you have a go at pausing the video, trying to reason about why these are wrong or right, true or false, and then I'll go through my examples and then I will show you very quickly your activities for today. Brilliant, great work if you had a go at that. Really important to get those verbal reasoning skills. Let's have a look at what you may have said. So this is my whole. This is what somebody thinks this is being represented as. Let's have a look. Is it true or false? Starting with our denominator. 4. Do I have 4 equal parts in my whole? 1, 2, 3, 4. Yes, I do. So that is correct so far. Now let's have a look at our numerator. 3, that means I have 3 parts, and that's shown by those 3 parts being shaded. So have I got 3 parts shaded? 1, 2, 3. Yes, I do. So this is correct. So I know it is true because there are 4 equal parts and 3 are shaded. Well done if you said that. Let's have a look at this one then. So let's have a look at my denominator. Do I have 3? Well, my denominator tells me how many equal parts there are. Do I have 3 equal parts here? Well, I've definitely got 3 parts, but are they equal parts? No, they are not equal because this part here is much bigger than these parts here. So I would say that this is false because the parts are not equal. Well done if you spotted that early. Brilliant. Time to have a go by yourself. I appreciate you listening to this lesson. It's new learning. It's going to take a long time. We're trying to cram in a lot of learning into these 4 days and the next 2 weeks really before we come back to school so that we can do some important things with you when you come back. So let's have a quick go and wrap this video up. Circle sheet, you need to find half of these shapes. Okay, so circle sheet, you just need to shade 1/2 of these shapes, 1/4 of these shapes, and 1/3 of these shapes. The semicircle sheet, you need to shade 2/4 of these shapes, 3/4 of these shapes, and 2/3 of these shapes. For the triangle sheet, you have got a selection of fractions and you need to write the fraction that is being shown by each image. The square sheet is where you need to do some reasoning. So just like we did a few minutes ago, there is a picture here of a fraction and a fraction that somebody has written down. They think that this fraction represents this. So they think that this representation here is showing 1/2. So you need to say, is that true or is that false? You just need to put a tick in the box. If it's true, tick true. If it's false, you can tick false here. Now, I'd like everybody, the reason it's like this is because I'd like everybody to have a go at that basic reasoning. However, the pentagon sheet is an opportunity for you to explain that reasoning, just like we did using the sentence starters a few minutes ago on those sides. So use this sentence starter to explain why each fraction in the table is true or false. So then you would go to A, and if you ticked that it was false, you would say, I know that A is false because, and then explain to me why it is false. Well done, everybody. You are all doing a fantastic job with your home learning, and I'm really looking forward to seeing the work that you send in. Please make sure that if you're only sending one piece of work in a week, that this is the work that you send in, because I'd really like to see everyone's understanding at this point on the fractions unit. Thank you so much for listening, and I will see you soon for another maths lesson. Bye, everyone.